Section 9.3, two dependent samples. On the first page, I have description of two independent versus dependent samples. So you may read this section to understand what's the main difference. But on section 9.3, we mainly discuss two dependent samples. And then there are some requirements here that the sample must be dependent, match pairs, and the n has to be greater than 30, or we should indicate that distribution is normal. In the formula, this mean of d is always equal to 0, so you don't have that part, okay? All you have is just d bar over st over n, and this is a formula for confidence interval. So when I go to the example, then you understand how we apply this formula. So in this example, we are talking about two dependent samples. One is list age of actress versus actors. And here is just 5 numbers, 5 different actors that we are using the ages. And what is D? D is the difference of these two, okay? So difference of these two numbers. For instance, the first one is 28 and 62, right? So what's the difference of these two is 28 minus 62, which is minus 34. Or the second number is 28 minus 37, and that gives you negative 9. So by subtracting these numbers, you came up with a new list. This new list, basically, if I want to use the calculator, I call this new list L3. All right. So for you to do the hand calculation and subtract this manually, what you could do, you could use the calculator. What you could do in the calculator is on L1 and L2, for L1, list all the numbers for actress. For L2, list all the numbers for actors. So here, and then D, which is the difference, I'll put that on L3. So here in the calculator on edit, see, I already put all the numbers in L1 and L2. Let me, since it's already done, let me see if I can, on the L3, I want to clear the list of L3, so I'll explain to you how it works. Okay. All right. So we have all the numbers in L1 and L2. So you understand that L3 is L1 minus L2. So the best thing is first you need to take the cursor up. So here, sorry. Take the cursor up there, okay? When you're here, then enter. Now that would bring it here. Now what I need to take all the numbers of L2 and subtract from L1. So you're going to do second L1 minus second L2. L1 minus L2. Okay? So when you enter that, it gives you all these numbers for L3. Now, you have a new list. We call this list D. Now I need to find mean of these numbers. Mean of these numbers, we call it D bar and a standard deviation of the D. So the new list is called D, and you want to find mean. That's the symbol of the mean. and a standard deviation. So for that, since you already have all the numbers, you go to Stat, go to Calculations. Calculator already has L3 for you because it understands that you did subtraction. So you just calculate. See, now sample mean is minus 10.2, S is 14.65. SX, which is just the S, standard deviation of the samples. These two numbers, you already have it. So we are going to use this for the problems. Now, next, on this page, see, first I kind of explained to you how to put all the numbers in L1 and L2 and do the subtractions. This is how you came up with. To show you how to find the sample mean and standard deviation, which sample mean is, D bar and X bar is the same thing, right? All right. In the formula, if you want to calculate the T, this part is always 0. So all I need to do is take these numbers and plot here. So T is minus 1.55. Now we need to find the T from the graph. But first, what was the claim? The claim is that mean of difference is less than 0. Okay, so mean of is less than 0. Let me see if I can find all those similar problems. All right. So mean of difference is original claim is less than 0. Opposite of that is always mean of D is equal to 0. Okay. So now we need to find through the graph. We need to find these numbers through the graph. On the graph, the best thing is to find, if you want to find T of a graph, first of all, is left tail is one tail. How do I know? H1 always, the symbol of H1, which is less, always determine what type of graph. Is it two tail or one tail? And if it's one tail, is it left or right? This is left because it's less than 0, right? How do I find these numbers? In your calculator, you go to inverse T, alpha, and DF. Alpha is 5%. Significance level is given in the problem is 5%, and DF is n-1, which is 4. Okay, so in that case, you just go to second. Go to second verse. Go to number 4, inverse T. Area significant level is 0.05, DF is 4, and then go ahead and paste. That gives you that number, minus 2.13. That's the number that we use here. Now, when these numbers, minus 1.5, it's greater than minus 2.1. So if that number fall here in a good area, not into the critical area, when your T of calculation fall into a good area, we always accept HO, and reject H1. So we reject the claim. Another part of this problem, we ask you to find the confidence interval. Confidence interval, this is a formula. And what is E margin of the error? Is T, ST radical. This T, you already have it. You put it here. You have S, you have radical F. That gives you 14.01. When you find 14.01, take that number and substitute here, plus or minus. That's what you get there for the interval. And then here at the bottom, I'll show you how to use the calculator to find all this, okay? Step by step. So if you go to stat test, t-test, put all this, the calculator will give you the t, you compare that with the t that you find here, make sure it's correct, and the p-value. Remember the p-value that you find to the calculator? If the p-value is greater than alpha, in our case, when we check the calculator, the p-value in the calculator is 0.097, is greater than 5%. So in that case, we accept HO. Remember, the p-value method and traditional method, these two must always match. So if you accept HO here, you should also see p-value greater than alpha to accept. These two should always match, okay? And then this is how to use the calculator to find your interval here. How do I come up with this 0.9 for the confidence level when you enter the calculator? Our problem is one tail and is 5%. If significance level is 5% and you have one tail, confidence level is 0.90. That's why we are using 0.90 here. So that should be your confidence interval from the calculator. We should kind of match this one, see? And then here on the next, this is just a calculation, the same calculation, but I just want you to see how they showed on the textbook. And on this page, you have those two calculations that I show you using the calculator. If you want to find hypothesis testing, you do T, you do this, and confidence interval, you do that. Now here, some people wants to know how we do the hand calculation instead of using the calculator. Remember, if you have a bunch of numbers, so first we subtract all this. So we have all these numbers, right? If you want to do a hand calculation for 5 numbers to find the mean is sum of d over n, means you add all these numbers, divide by 5, and standard deviations is from this formula, okay? And that's how to just show you how to do the hand calculation. But I guess it's always recommend to use the calculator. It's easier to use. It's problem. And then I'll show you an example here, just one example, so you could understand it better. All right, so that's the end of this meeting.